mathematicians confuse reality with precision or reality with what is clear, because that's one of the main epistemological problem of quantum mechanics. It's the closer you get to what is supposed to be the point, the less clear it is. And at the end, you're wondering, one can wonder if the fact that you desire to see things clear is not pathological, or is not something that, because we need to see clear things, so distinguished things, as you said, discrete things, in order to live on a evolutionary point of view, because otherwise we will not be able to orient ourselves to know what we are going to do with our lives, where we are going to go. If there is no different object, you don't even know where you're going, in what room you're going. You're entering somewhere and you're going somewhere else, etc. But when you get closer to closer, it becomes less and less clear, because maybe the very nature of reality is not clear. It's the same problem with probability. Because you have a way to say probability are just something that it's what you use when you don't know yet what is really there. When you don't know what is really there, you use probability. For instance, let's take a coin. Let's take a coin. We are just throwing a coin, and because we don't know yet, or we don't have the instrument, or we are not able to understand and to take into account all the parameters, like the wind, the structure, the aerodynamic of this specific piece of material, and even the drawing on it will change a little bit of the interaction between the atmosphere and all that, and the dynamic and the force I projected it, and you are not able to do that whatsoever. You call it random, and you say it's just there is a half chance for this coin to be on this face and half chance to be on the other. Yeah. But in fact, there is this fantasy that if you knew exactly what are all the parameters, you will know very simply, in a way, like precisely on what face it will be. Except that with quantum mechanics, you know that is not possible, but it's not possible per se. It's not possible in itself. Why? Because in fact, we could say that on a microscopic way, the closer you get, the closer you see that reality itself is interaction, is the infinite interaction that does not allow causality, like simple causality, to work. And in the macroscopic world, what we call randomness, but some kind of a randomness that we fantasize we can eliminate if we knew everything. Like if we have I will say, a mathematician engineer mind, not a mathematician pure mind, like a mathematician engineer mind, you figure that on a macroscopic way, one moment or another, you'll be able to isolate all the parameters. But in fact, you can't. You can't. Why? Because the very nature of the world will be to be infinite. So the parameters being infinite, even for something macroscopic, you can never forecast what will actually happen. You can just be probabilistically, it will happen this way. So that's the difference between probability in a positivist mind that think that probability is just a step before real science, and probability as the world itself is probabilistic. So you can't go beyond probability because it will prevent us from being alive, prevent the world from being alive, like being free of, randomness is not something that in itself can be overcome.
Okay, first of all, mon cher ami, un cri de coeur. The cri de coeur is, the gods weep looking at us, at the human race here.
Wow.
They weep. It's a mess. For me, it's not real. The human condition is a mess. It's all mush. Politics, everything makes me weep. I'm not God, or I'm not the gods.
But you're weeping with it.
But I weep. That's why I became a mathematician, because in mathematicians, things are clear and precise. In the human world, nothing is clear and precise. It's all a mess. And if you have a bigger army, then you have the truth, right? So this is a world I reject. That's why I became a mathematician. We hide in a better world, a different world at least,
Wow.
completely different.
I didn't want to miss that. That's
Okay?
good. Yeah.
So that's the first thing I wanted to say, which means I'm unable to deal with reality, with human life, with the real world where my wife functions a lot better than I in this world, okay? But I deliberately, to do mathematics, you have to shut that world away, that messy world.
Randomness, you mean.
No, I deny randomness.
Yeah,
I reject
I'd say she
randomness.
accepts randomness.
Right. I don't want to know the news. I don't want to know the news because I'm thinking about a different world, a world where things make sense.
You're so
And in this world,
Platonicians.
it doesn't make sense. That's the first thing. Now then, there's the big question of what is probability theory? The normal notion is that probability is something, Laplace probably says this in his wonderful book on Essai philosophique sur les probabilités. It's because we don't know something. So that would make probabilities not have any real existence. It would just be a way of dealing with lack of knowledge.
Yeah, step two.
I agree, this is the normal view of what probability. However, I have shown that probabilities and randomness have an intrinsic fundamental role in pure mathematics. It's not just because the messy real world we need probabilities, because sometimes we can't calculate what's going to happen. We can't, the Laplace demon, we can't be the Laplace demon. That's the normal view of probabilities. But what I've shown...
The Laplace demon is God for you, because it's the one that knows everything.
Right. When you go into pure math, I've shown that there are probabilities and randomness in pure mathematics itself. And there, probability theory is not a way of dealing with ignorance. It is a part of the fundamental reality of pure mathematics. Okay? So it's not just that we deal with probabilities because we don't have enough information to actually calculate what's going to happen, which is the normal view, I agree, for 99.99%.
It's not my view, it's what I tried to say. It's not my view.
You expressed it very well, and I'm sure Laplace would agree. But the maybe in a way the most revolutionary aspect of my efforts has been to show that randomness is not just something we need to deal with uncertainty in the real world, with our lack of knowledge, with human limitations, but it is something that has an intrinsic existence in pure mathematics itself.
You know what?
Yeah.
I just deeply agree with that.
Oh,
that's what I wanted to say.
But I devoted my life to prove this. It wasn't true before the omega number and before a definition of randomness.
I'm sure, and that's the reason why we love you. And your thoughts. That's exactly that. And it's just what I wanted to mean.
Most people don't understand that, but you're much deeper than most people.
No, but it's exactly what I wanted to mean. I said, remember that it's some kind of a fantasy, like the Laplace way of thinking that it's a question of parameters, and it's what I wanted to mean. And the other, and it's the reason why I think what is interesting is that as we could say, your deep mathematical intuition about randomness, it actually reaching a point where it makes it coherent with quantum physics on a physical point of view. Because I will say that in the debate between Niels Bohr and Einstein, of course you'll be on the side of Niels Bohr, because Einstein, he will say probability. He said that. He said probability is just that you missed something.
Right.
And you are not saying that, and I'm not saying that. And Niels Bohr said, no, we are not missing anything. It is not, probability are not, we'll say, an instrument They are not only an instrument that is an imperfect instrument because we haven't reached the point where we are able to see the real thing. It is not that. It is the real thing that is probabilistic. It's what he's trying to tell Einstein, but Einstein will not understand it. And he said, no, it is the world that is probabilistic. That's the reason why they added probabilistic. And they say it is the tissue of reality that is probabilistic. That's the reason why, to come
Agreed.
back.
This is the real
Exactly.
intellectual rupture between Einstein and Bohr,
Exactly.
between classical physics, which is deterministic,
Exactly.
and quantum physics, which says
Exactly.
the reality is probabilities.
Exactly, and that's why I tried to say, but I wasn't clear enough, in coherent enough. I understand it now.
Well,
when
now
I'm
it's
talking
getting
to you.
clearer.
You know, it's just that on the microphysics point of view, the closer you get to reality, it's more real, and when it's more real, it's more probabilistic. It's what I want to say. It's the other way.
That's what quantum mechanics says. Now, as a physicist friend of mine in Vienna, Karl Schwarzschild, said, it's disputable whether the real world is deterministic or probabilistic. Maybe quantum mechanics is wrong. But don't you one could argue. However, what he said, what I've done, he said, that indisputably randomness exists in the world of pure mathematics. In the physical world, some people, Einstein thought no, Niels Bohr thought yes. Quantum reality, as we saw in the Science Week, the talks by Hervé Zwirn and another gentleman made it clear that reality in quantum mechanics is getting more and more unreal. Anton Zeiliger said that in the Science and the Search for Meaning, also meaning that that what he sees as the fundamental is what did he say? Was it information and randomness?
Yeah.
But space and time are looking more and more unreal all the time. This is the problem with the real world.